Welcome to second lesson in relativity. Here we will discuss the Michelson-Morley experiment and the implications of this negative result. As already discussed, we have seen that the scientists of the 19th century believed that light can travel through vacuum only with the help of some material medium. And so they assumed a hypothetical material medium called ether. It was assumed to be filling the whole space, and this hypothesis is called the ether hypothesis. So the aim of Michelson-Morley experiment was to determine the existence of this ether medium. The principle of the experiment was to detect the velocity of Earth in the ether medium. For that, they used a setup called the interferometer. Later, that interferometer is named as Michelson's interferometer. And in the Michelson's interferometer, as the name suggests, it works the principle of interference of light beams. So it was a very sensitive instrument. And they used, in their experimental setup, there was a light source emitting monochromatic light waves. And the light waves coming from that light source will incident on a beam splitter, which is a half silvered glass plate. Beam splitter means it will split the light rays into two parts. One part will go in this direction, that is in the perpendicular direction towards a movable mirror M1, plane mirror M1. And this next part moves towards, passing through this beam splitter, moves towards another mirror, fixed mirror M2. So the light rays reaching at the mirror M1 and M2 gets reflected back. So after reflection, these light rays reach the telescope. The light rays reflecting from the mirror M1 reach the telescope, and from mirror M2 it will reach the beam splitter, and after reflection it will go back, it will go into the telescope. So while observing the telescope, we can see two light rays, and these two light waves will interfere, producing dark and bright bands. What was the principle is, if there is a shift in the path difference between these two light rays, the interference pattern will shift. We will get interference pattern dark or bright depending on the path difference between these two light rays. If the net path difference between these two light rays is 0, lambda, 2 lambda or 3 lambda, or it is a multiple of wavelength lambda, we will get a bright band. If the path difference between the two reflected rays reaching at the point at the telescope is lambda by 2, 3 lambda by 2 or 5 lambda by 2, etc., then we will get a dark point. So this was the experimental procedure or the principle of the experiment. And they assumed that the velocity of Earth v with respect to the ether is assumed to be v, and we also they assumed that ether is at rest with respect to the sun, because sun is the center of the solar system. So ether is a universal medium which is at rest, and with respect to ether everything is moving, and they assumed that sun is at rest with respect to ether. So the velocity of Earth with respect to ether will be equal to the velocity of light Earth with respect to sun. And the velocity of Earth has a magnitude of 3 into 10 raised to 4 meter per second. It is the orbital speed of Earth around the sun. So they assumed that Earth has a velocity of 3 into 10 raised to 4 meter per second with respect to ether. And Earth is moving in this direction, in the direction of AB, that is one of the arm of the interferometer. Now, the time taken by the light rays to reach from A to B, you can see that the light coming from the source will reach at the beam splitter simultaneously. There will be no path difference. And at the source they are split into two parts. One part moves to A, C, and then comes from C to A. Another part moves from A to B, then comes from B to A. So the path difference will be AC plus CA minus AB plus BA. That is the path difference between the two rays. After that, they are coming simultaneously to the what is called a telescope. So there is no path difference here also. So the path difference is AC plus CA plus minus AB plus BA. That is the path difference. So we have to find that path difference. In order to find that path difference, first of all, we will calculate the time taken by these two light rays. So first we take the time taken by the rays to reach from the beam splitter A to the mirror B. So that time taken will be the distance between A and B is L. And C is the velocity of light in either. And V is the velocity of Earth with respect to either. So the velocity of light with respect to Earth will be C minus V. Because Earth is moving with a velocity V in this direction and light is also moving in the same direction. If two objects are moving in the same direction, then their relative velocity will be C minus V. So the time taken by the light ray to reach from A to B will be L by C minus V. Similarly, when it is reflecting back, the light rays will move from B to A. So the time taken at that time will be the distance by relative velocity. Here the relative velocity becomes C plus V because the light is moving from B to A and Earth is moving from A to B. So their velocity will get added. So the relative velocity becomes C plus V. So the total time taken by the ray to reach from A to B and then from B to A is L by C minus V plus L by C plus V. That becomes 2LC by C square minus V square. Similarly, now we take the time taken by the light ray to reach from A to C and back from C to A. Now as the ray travels from A to C, the Earth is traveling in this direction. So the position of the mirror C will be changing to another position, say C2. Then as the ray is reflected back from C2, then the beam splitter will be moving from the position to another position, say A3. So this will be the ray of light with respect to either. This will be the path of the ray of light. So the time taken between A and C, that is between A and C, will be equal to that we have to find. So for that we will find this distance AC2. Now that distance AC2 is equal to root of this distance is d by 2. This total distance, that is the distance moved by the beam splitter or the distance moved by Earth during this time interval, it is equal to d, small d. So as the total distance is small d, the half distance will be d by 2. So we get AC2 is equal to root of d by 2 square plus L square because this distance is here, L square. Now if T1 is the time taken from A to C and then from C to A, if it is the total time taken for the round trip of the ray, then we have d is equal to, d is the distance travelled by the Earth during this time interval. That d is equal to the velocity of Earth into time taken, that is d is equal to Vt1. Therefore we get the total distance AC to A3, that is the total distance moved by the light ray in going from beam splitter to the mirror, then again back to beam splitter. It is equal to AC to A3, that is equal to 2 into AC2, that is equal to 2 into root of d by 2 square plus L square, that is equal to 2 into this d is Vt1 by 2 whole square plus L square. So we get Ct1 is equal to, because here this one is equal to, it is equal to 2 into root of Vt1 by 2 whole square plus L square. Therefore squaring this expression, here it is equal to Ct1 because C is the velocity of light in the what is called in the ether. It is assumed to be C is the velocity with respect to ether. So that total distance travelled by the light in either medium will be Ct1 because T1 is the time taken. So that Ct1 is here, it is equal to AC to A3. So that Ct1 is equal to this distance. So squaring we get C square T square is equal to V square T1 square plus 4L square. Therefore, solving this equation, we get T1 square is equal to this much, or T1 is equal to 2L by root of C square minus V square. So we get two time. The time taken by one of the ray, it is T2 equal to 2LC by C square minus V square, and time taken by the second ray, it is T1 is equal to 2L by root of C square minus V square. Now we will find the time difference. The difference in time is T2 minus T1, that is 2LC by C square minus V square minus 2L by root of C square minus V square. That is equal to 2L by C if we take c square has common factor here, c and c square gets cancelled, so 2l by c into 1 minus v square by c square minus 2l by, if we take c square outside, it becomes c into root of 1 minus v square by c square. That is equal to 2l by c can be taken out because it is a common factor. The remaining will be 1 minus v square by c square raised to minus 1 minus 1 minus v square by c square raised to minus half. Now we are going to expand this one using binomial expansion. And it is the fact that c is much greater than v, because velocity of light in vacuum is measured as 3 into 10 raised to 8 meter per second, and velocity of earth with respect to ether, which is assumed to be velocity of earth with respect to sun, it is 3 into 10 raised to 4 meter per second. So this is v is much negligible than c. So while expanding, we have to keep only the first term. So the first term will be 1 plus x raised to n is 1 plus nx. So it becomes 1 plus minus 1 into minus v square by c square. So it becomes plus v square by c square minus 1 plus. This expansion becomes 1 plus nx becomes minus 1 in minus 1 into minus 1 by 2. So it becomes 1 by 2 into v square by c square. So expanding, we get 2l by c into v square by 2c square, that is equal to lv square by 2 lv square by c cube. So this is the time difference between the two rays. So the path difference, so that is the difference in path traveled by the two rays will be equal to time difference into velocity, that is equal to c into delta t, that is equal to lv square by c square. So this is the expected path difference. Now the experimental setup was rotated. So that rotated means it was rotated through 90 degree. Now if it is rotated through a 90 degree, we can see that the path, the arm AC becomes parallel to the speed of light and the arm AB becomes perpendicular to the speed of light. So what happens here, there will be a phase shift in the opposite direction. In the opposite direction means, so the total path difference becomes c delta t will be equal to 2l v square by c square. There will come a factor of 2, because now the positions of the rays are shifting, so they will get a path difference in the opposite direction, so that the total path difference between these two rays in the two positions, that is while rotating the interferometer from position 1 to position 2 through 90 degree, the expected path difference is 2l v square by c square. And so the fringe shift, that is the shift in fringe, it becomes path difference by wavelength. This much will be the fringe shift, because for each wavelength lambda, the fringe will be shifted by one fringe width, because a dark becomes a bright one by a shift of lambda by 2. If another lambda by 2 is shifted, it becomes again bright. So a bright first becomes dark, then becomes bright, means a fringe has shifted through the telescope. So the expected fringe shift was 2l v square by lambda c square. And for the experimental purpose, they used sodium light. The wavelength of sodium light was 580 nanometer, and the distance between the beam splitter and any one of the mirror was 11 meter, and they get this 11 meter distance by multiple reflections. And the velocity of sun, velocity of light, earth with respect to ether, which was assumed to be the orbital speed of earth, which is 304 meter per second, and the velocity of light. So putting all these values, we get the expected phase shift is 0.4. So the expected phase shift was 0.4, and they were not able to find any appreciable fringe shift. Their apparatus were very sensitive. That apparatus was able to detect even a phase shift as small as 0.01. So the phase shift of 0.4 can be easily detected by the apparatus. So they repeated the experiment at different places and at different seasons, but always the result was negative. So this is the most famous experiment, and this is called as the the most famous failed experiment. So the negative result indicates that speed of light is same for the two perpendicular paths, which indicates the absence of either. Or in another way, we can say that the speed of light in vacuum is a constant for all observers in all inertial frames. Or the speed of light is independent of the velocity of the reference system. If the frame is inertial, then they will measure the speed of light in vacuum as c. It is independent of the velocity of the frame. This was the result of Michelson-Morley experiment. And it also indicates that there is no such medium called as either. So after the result of the Michelson-Morley experiment, the either hypothesis was rejected. Actually, historically, after the result of Michelson-Morley experiment, they were explaining this as an either drag because they assumed that either was dragging along with the interferometer, but later it was verified that there is no such medium called as either. So this negative result explains the fact was that either is absent. So that hypothesis was rejected. But another important point is this does not agree with the Galilean transformation, because by the Galilean transformation the velocity of light will depend on the velocity of the frame of reference. But here it is found that the velocity of light in vacuum is a constant. It is independent of the velocity of the frame of reference. So the implications of this experiment and the relativity will be discussed in the next class. So thank you for watching this video.